Sat-Fi film report number 19 covers this during the period September, October, and November 1967. A historic milestone in the Saturn V program, launching of the first Saturn V flight vehicle, was successfully accomplished this quarter. Launch preparations for the 363-foot-tall vehicle, designated Apollo 4, got underway immediately following its rollout on August 26th from the Vehicle Assembly Building at Kennedy Space Center to Pad A of Launch Complex 39. Primary mission of the flight would be to flight test the launch vehicle, which was developed under Marshall Center direction, and to test the Apollo spacecraft heat shield upon its re-entry into the Earth's atmosphere at speeds similar to those reached from a lunar mission. Checkout of the vehicle's mechanical and electrical systems progressed smoothly throughout the first month of the report period, in preparation for the Vital Countdown Demonstration Test, or CDDT, which began on September 30th. The CDDT encompassed a complete dry run of the launching of the Apollo 4, including a practice countdown, actual fueling, and simulated firing in flight. By means of the CDDT, engineers were able to discover and eliminate any problem areas. Among those encountered during the exercise were the ground checkout computers, first-stage helium pressure regulators, launch vehicle batteries, and moisture in certain electrical cables and components. After successful solution of these problems and completion of the CDDT on October 13th, final preparations, tests, and checkout operations got underway to assure flight readiness of the huge space vehicle. 3 weeks later, at 8:30 p.m. Eastern Standard Time, on November 6th, the terminal countdown was started T-minus 49 hours. The computerized countdown, with a built-in hold of 7.5 hours, proceeded smoothly on schedule. The launch would mark several momentous program milestones. First flight test of a vehicle of such size and complexity, first complete vehicle flight test, first flight of both the S-1C and S-2 stages, and the first engine restart in orbit of the S-4B stage. A flawless liftoff on schedule at 7 a.m. Eastern Standard Time, November 9th, sent the vehicle on its way to what would later be described as a virtually perfect flight in every respect. Launch tower clearance was maintained during liftoff, with a yaw bias accomplished as programmed. To escape the 400-foot-tall launch tower, 16 seconds were required by the 6.2-pound space vehicle, its 5 first-stage F1 engines generating a total of 7.5 million pounds thrust. Telemetry data indicated the S-1C stage engines, stage propellant utilization system, pressurization system, and pneumatic control system all operated satisfactorily and within expected tolerances. Maximum bending moment was well below design values. Yaw, roll, and pitch programs in the S-1C were accomplished as expected. Structural temperatures and aerodynamic measurements proved well within predicted values. At T plus 135.5 seconds, the S-1C inboard engine cut off as scheduled, to be followed 15.3 seconds later by outboard engine cutoff. Onboard cameras, later ejected and recovered, showed the S-1C separating and falling back toward the Earth. Then, at T plus 153.3 seconds, ignition of the S-2 stage occurred. 29 seconds later, the S-1C S-2 interstage also separated and fell away. Separation was extremely smooth and clearances were adequate. As in the case of the S-1C stage, all systems of the S-2 stage operated properly and within expected tolerances. The S-2 stage's 5 J2 engines, burning liquid hydrogen and liquid oxygen and generating 1 million pounds thrust, shut down as scheduled at T plus 519.8 seconds. Within the following second, S-2 separation and S-4B stage ignition were accomplished. These were not recorded by onboard cameras, since orbital altitude had been reached by then and cameras could not have been returned to Earth. The S-4B stage's single J-2 engine cut off at T plus 665.6 seconds, and the 280,000-pound third stage instrument unit spacecraft combination went into orbit at 117 statute miles. After an 88-minute two-orbit coast period, the S-4B stage engine was restarted and operated for 5 minutes to send the Apollo on the way to its re-entry test mission. Pressure in the S-4B fuel tank was somewhat low at second burn initiation, but stabilized at an acceptable level. The Saturn V instrument unit performed satisfactorily throughout the entire flight. Climaxed by the Apollo spacecraft's re-entry and recovery in the Pacific Ocean, 8 hours and 40 minutes after liftoff, Apollo 4 had achieved every one of its primary and secondary missions in a textbook perfect flight. With the highly significant initial launch a success, attention now focuses on the second Saturn V flight vehicle, designated Apollo 6, which stands erected in the KSC Vehicle Assembly Building. Vehicle checkout is in progress with no serious problems reported for a scheduled launch early in 1968. The S-1C stage for the third flight vehicle has been removed from storage at Boeing Michoud, New Orleans, and is now undergoing checkout and post-delivery storage modifications. Shipment to KSC of the S-1C, as well as the upper stages and instrument unit for the third flight vehicle, is slated for late December. The S-1C stage for the fourth flight vehicle has been placed in storage. All elements of the fourth vehicle are due at KSC in the spring of 1968. The S-2 stage for the third flight vehicle was successfully static tested this quarter at the Mississippi Test Facility and is now undergoing post-static checkout operations. The first S-2-3 firing for 64 seconds was primarily to check out the newly completed A-1 second stage test stand at MTF. A second firing, of full duration of 384 seconds, served to acceptance test the S-2-3 stage. Initial use of the new A-1 stand this quarter now completely activates MTF. The S-2 stage for the fourth flight vehicle arrived at MTF in late November from North American Rockwell Space Division at Seal Beach, California. S-2-4 weighs some 3,000 pounds less than previous stages due to thinner propellant tank walls and lighter structures. A full duration acceptance firing is scheduled during the next report period. After removal from storage, the S-4B for the third flight vehicle is now in post-static checkout at the McDonnell Douglas Sacramento Test Site in California. The S-4B stage for the fourth flight vehicle has also been removed from storage and is undergoing checkout. Retest of the instrument unit for AS-503 began in mid-November in the checkout stand at IBM Huntsville. Retest was necessary after incorporation of various IU modifications had been accomplished. Completion of checkout and shipment to KSC is due in late December. Checkout of the instrument unit for AS-504 was finished in late October. Stages and instrument units for subsequent Saturn V flight vehicles are in various phases of fabrication, assembly, checkout, and testing at prime contractor facilities, with no serious problems or slippages being encountered in any of these operations. Refurbishment of the third stage Beta 3 test stand at SACTO was completed early in the quarter, and cold flow testing on the stand began in mid-October. The stand, which had been damaged in the S-4B 503 explosion early this year, will be operational in early December. Investigations and tests of stage program-related items, such as the S-4B stage propellant tank repressurization helium storage sphere, continued during the report period. Purpose of these tests was to demonstrate to NASA the ability of test specimen to meet design requirements. Failure occurred at 8,300 psig, approximately 300 psig above the design minimum burst pressure. Because of the high burst pressure and the fact that the failure did not occur along the weld seam, the test was considered a success. A test program to determine the explosiveness of polyurethane foam insulation dust was conducted by the S2 stage contractor at its Downey, California facility. The tests were performed because foam dust is created when foam insulation is machined at the S2 manufacturing plant. Results of the tests indicated that the dust does not create an explosion hazard when its content is limited to 1/100th of an ounce per cubic foot. S28 is the first stage to be insulated completely with polyurethane foam. Application of the foam is accomplished in about 25 minutes using 3 spray guns. After 48 hours, the foam has cured and is ready for machining to a thickness of 2 1/4 inches. During spraying and machining, the entire S2 stage is rotated about its longitudinal axis. A Thor missile fuel tank provided by Douglas McDonnell has been insulated with the spray-on foam and instrumented with strain gauges and thermal sensors at North American Rockwell's Seal Beach facility, and will be shipped in early December to Sacto to undergo cryogenic tanking tests to evaluate the new insulation. The unqualified success of the first launching of a Saturn V flight vehicle provided a spectacular highlight for a report period which witnessed steady and wide-ranging progress throughout the Saturn V program.